Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the IR spectroscopy. In that we had discussed the carbonyl compounds, and what we are going to discuss today, the remaining part of that carbonyl compounds. And as we know that carbonyl compounds is generally referred which containing as the one common group, which is C double bond, that is referred as a carbonyl group. And as we know that there are the number of compounds are present. For example, suppose we have R C double bond OH, that is a aldehyde, R C double bond O R dash, which is a ketone, and R then C double bond O OH is the acid, and R C double bond O R dash is known as a ester, and where R C double bond O X is known as a acid halide, then R C double bond O NH2 is known as amides, and R C double bond O C double bond O R dash, or maybe as R, is known as acid anhydride. These are the, we know that it is a aldehyde, this is a ketone, this is a acid, and this will be the ester, this is acid halide, and this will be the amide, and this is a acid anhydride, anhydride. These are the general formulas which I have written on the blackboards. So aldehyde, ketone, acid, ester, acid halide, amide and acid anhydride. If you observe this structure carefully, the common thing present in these compounds are carbonyl group, and that carbonyl group, as we know that it is referred as functional group. Functional group, in short, we are known that site of reaction. Site of reaction means whenever we are adding as a reagent, the part of the only that specific part is go on changing, other part of the organic compound which remains unaffected, it remains as it is, and that specific part is generally called as or referred as functional group. And here, how will you distinguish the following pair by IR spectroscopy? These kind of question appear in an exam. Suppose such a type of the question when would be appearing in the exam, then how do you answer it? So there is a, for example, let us see here aldehyde and the ketone, one of the simplest example I am taking over here. Let's see this one, CH3 C double bond O H, and another one CH3 C double bond O and CH3. If you Observe these two structure carefully. What do you see over here? Look at both the compound containing as a carbonyl group, which is a common in both the structures. And if you put these compounds separately and obtain as a spectra, and if you interpret that spectra, if you analyze that spectra, what would you observe there? There you would observe the compound which will produce here let us see, there is a carbonyl group. The appearance of absorption peak or band around 1715 per centimeter shows presence of carbonyl group due to the carbon oxygen double bond stretching frequency. This is one of the characteristic of carbonyl compound. It appear near 1715 per centimeter. These signal or band or peak clearly suggests that there is a presence of carbonyl group. Look at here. Now if you run the spectra, if you done the spectra of acetaldehyde, you will observe there are two peak, strong and the prominent peak. You would observe in this compound one around 1720 per centimeter and another one which is around 1750 to 2850 per centimeter. Means aldehyde group always produce two prominent or the significant peak, one due to the carbonyl group and another due to the CH aldehydic group, and these are the two prominent peaks observed in a aldehyde, and from that the organic chemist draw the conclusion. They will say there is a aldehyde group is present, because aldehyde group is always present at the end of the organic compound. And if you see here in acetone, the common name of this compound is acetone. Let me write it here, acetone, which is a common name of that organic compound. Do you remember, or can you tell me what will be the IUPAC name of that acetone? Acetone is a common name, it is well known, and anywhere it is known by its common name. But do you know the IUPAC name of this compound? As we know that IUPAC, the full form of IUPAC, the International Union of Pure and Applied Chemistry, there are the certain rules are there Rule number 1, select the longest continuous chain and give the number in a such a way that the functional group should get the lowest possible number, and then suppose is a ketone is there, then the last suffix should be ONE. So in that way we generally, by following the IUPAC rule, we can able to, or anyone can able to give the correct IUPAC name of the organic compound if they are knowing the rules. And because that committee has given us that rule, so look at here 1, 2 and 3 carbon atom in the straight chain, and at 2 position there will be a carbonyl group, so that you can call it as a 2 prop, indicate as a 3 carbon atom in the propanone. Last suffix is ONA. Propane is the parent name of this, and ONE is the last suffix you joined here, so you can call it as a 2-propanone. Either you can write like this, or you may write like this, propane 2-ONE. That would be the name of this compound. 2-propanone you can call it, or you can write it as a propane 2-ONE. So there are the two ways. And here the common name of this compound, any aldehyde, last letter is aldehyde. So there are 2 compounds, so it is called as acetaldehyde. Acetaldehyde, it is the name of this compound, and the IUPAC name, only 1 and 2 carbon atom in the straight chain. You can give the number starting from the carbonyl carbon should carbonyl carbon must get the first number. You start always from that, because that carbonyl carbon is a most oxidizable group, and therefore it should get the first number. And the IUPAC name of this compound, as we know, that ethanol. Last suffix should be Al. Al indicate as a aldehyde group is present over there. Ethanol is the IUPAC name of this compound, and acetaldehyde is a common name of this compound. So that are the thing. In addition, that information I am providing over here. But here in the exam you should remember, you write down the 2 peaks. The peak, the IR absorption peak at 1715 per centimeter due to the carbonyl stretching frequency, while the IR absorption peak at 1750 to 7850 per centimeter is due to the aldehydic CH stretching frequency. From these 2 prominent peaks, we can say that the given organic compound is a aldehyde, whereas in the second structure, the compound which the IR absorption peak appear around 1715 per centimeter suggests that presence of carbonyl group, only 1 signal is produced. It means that it is due to the ketone, and they in aldehyde always exhibit 2 peaks, and from this we can easily distinguish aldehyde from ketone, right? So this is a actual example I have taken, but in general here always remember aldehyde gives 1720 per centimeter, and the peak which is due to the CH stretching 2750 to 2850 per centimeter. 2 peak, prominent peak, strong peak observed in IR spectra, then we can say that this peak is due to the, but that value you have to provide over there. 2 peak it indicate as a aldehyde giving as a this peak, one at 1720 and one at 2750 to 2850, clearly suggests that there is a aldehyde group is present. But here the suppose as a only as a carbonyl group, it produces as a 1715 per centimeter, that is only one peak is observed around 1715 per centimeter. In this way we can easily find out the IR frequency. We can easily distinguish aldehyde from ketone by observing the number of peak present in the IR spectra, right? So that are the thing you should remember over here. Now if you see another structure which is acid, and as we know that acid having as a general formula RC double bond OH, and that RC double bond OH R may be aliphatic compound or the aromatic compound, but here the carbonyl compounds also present over there. And carbonyl compound, as we know that those organic compound containing as a carbonyl group, the peak is appear around 1700 per centimeter, and that peak around 1700 per centimeter either increase plus minus 100 or plus minus means 17 to, if you add as 118, and if you minus, so that becomes as a 16, something around 90 you can consider. So then this clearly suggests that, clearly indicate that there is a presence of carbonyl group. And as we know that carbonyl groups are present in a number of different organic compound, which some of them I have written over here. The lactone, which I have not written over there, or lactam, that is also containing as a carbonyl group. So let me give some little bit information regarding as a lactone means what. The ester group which is present in a open chain, that is called as the ester. If that functional group involved in the cyclic, then it is a termed, or then it is referred as lactone. Understood this? Now lactam means, you know that the open chain like as a amide, it is open. Amides are primary, secondary or tertiary, so but they are the amide. But when that amides are present in a ring, involved in the ring, then it is referred as a lactam. So these are the thing you should remember as far as lactone, or what do you mean by the lactam. At MSc level you are going to study that one, but at this moment we do not require that things, but I just mentioned that one. But here the acid which will give the IR frequency near about is 1700, let us see, 1710 or something around that, 1710, let me write here, 1710 per centimeter. And another acid also produces two prominent peaks, one around 1710 per centimeter and another near 2500 to 3600 per centimeter, and that 2500 to 3600 per centimeter strong and broad peak is observed due to the presence of hydrogen bonding over there, because there is a hydrogen atom present in a acid. And as we know that Why it shows as acidic properties? Due to this proton, because these proton are get dissociated, it produces as a H plus, and that's why it shows as a acidic property. And whatever conjugate base is formed, that will be stabilized due to there are number of factors, and that can stabilize the conjugate base. We are not going to see here details of those factors, but here remember why it is acidic, because there is a proton which is responsible for acidity, and the OH stretching frequency that is appear around 2500 to 36 per centimeter, that is a strong, and the broad bond is obtained, band is obtained. Why this type of the wide range? This due to the hydrogen bonding, and everybody knows that there are two kinds of hydrogen bondings are present. I think I already mentioned those two type of the hydrogen bonding, and everybody knows that. Still let me tell, one is the intermolecular hydrogen bonding and another one is the intramolecular hydrogen bonding. While when we will study factor affecting IR frequency, that time we are going to learn, we are going to discuss how hydrogen bonding, it may be as a intramolecular hydrogen bonding or the intermolecular hydrogen bonding, how they play an important role either in increasing or decreasing IR frequency. Why the some of the peak appear broad, some of them appear sharp at that particular region, and the detailed explanation about that intramolecular hydrogen bonding and the intermolecular hydrogen bonding we are going to discuss. But here just remember, intermolecular hydrogen bonding means for hydrogen bonding two molecules are involved, maybe same or different. That type of the hydrogen bondings generally referred as intermolecular hydrogen bonding, and another case intramolecular hydrogen bonding means the hydrogen bonding occur within the molecule. That type of the hydrogen bondings are generally referred as or called as intramolecular hydrogen bonding. Now where we are, so this is the information. Or if you compare, one is a simplest, one is a let us see one example I am going to give over here. Suppose you have a one is a HC double, let us see one more. Okay, C double bond OH here maybe as a another one compound, and one may be as another one C double bond O and OH. Let's see there. Observe these two compounds. This is the compound number 1. This will be the compound number 2. The compound number 1 is called as a formaldehyde, and the compound number 2, which we know that everybody know that the name of that compound is acetic acid, right? Now how will you distinguish the following pair by IR spectroscopy? And it's a very simple to explain with the help of IR spectroscopy, you just have to have to mention only the IR frequency, that bands, that peaks, and this peak is due to this peak is due to this, and that's it. And that is nothing but as an answer of that or the explanation of that question. Remember. So here, how will you distinguish the following pair by IR spectroscopy? Look at, this is aldehyde, and as we know that aldehyde generally produce two signals, one due to the carbonyl stretching frequency, another one due to the aldehydic CH stretching frequency. These are the two prominent peaks observed due to the aldehyde group. One, generally here we have seen in case of here, right? But here the acid will produce this type of the peak, 1722, one peak, and one is around is a 2500 to 3600 per centimeter. So one is due to OH and one is due to carbon. In aldehyde also produces a two prominent peak. Carboxylic acid also produces as a two prominent peak, but the common noticeable peak due to the carbonyl in either molecule are their size and shapes are generally is the same, and therefore that peak, carbonyl peak, is the most easiest peak to recognize the IR spectra. It is a very prominent, it is a very recognizable peak present in a IR spectroscopy. It is the easiest way to recognize the IR spectra of that carbonyl group. The organic chemist immediately say that in this spectra whether the carbonyl group is a present or absent. If it is absent, what else? If it is a present, and that the exact position of that absorption peak is a slightly shifted either higher side or lower side, that is again depending upon the factor, which factor we are going to discuss in our near future lectures. Right now that is not the time to discuss that one, but in a near future we will discuss that one. Here just remember, here also we are getting as a two peak, aldehyde also produce as a two peak, carboxylic group also produce as a prominent two peak, but the peak due to the presence of carbonyl is common in both the compound because both containing as a carbonyl group, but the signal due to the carboxylic group is in the range 2500 to 3600 per centimeter. That signal is absent in the aldehyde, and the new bands are appear in aldehyde near 2750 to 2850 per centimeter. That suggests the presence of carbonyl group is present, not the hydroxyl group. So in this way we can easily distinguish aldehyde from acid. Here we have taken the simplest example. I have explained this with the help of this IR spectroscopy. Now let us move on to the next one. Next, which is a ester, and as we know that ester having the general formula R C double bond O R dash. Now here let me take an example. Here suppose we have this one CH3 C double bond O, then CH2 CH3 ethyl acetate. Now how will you distinguish acid from ester? See over here once again the carbonyl group which is present here. In this case the IR absorption peak appear around 1740 per centimeter, and another prominent peak due to that CO is appear around 1100 per centimeter, 11 to 1300 per centimeter. Here the value of carbonyl group as compared to this ketone is a slightly higher. Why that higher? It is once again the factor affecting the IR frequency. That time we will see the details of that. But here, if the ester group is present, the carbonyl frequency appear around 1400 per centimeter. So that is what we can call it as an indication of ester group present here. And in addition to that, one new band is appear, new signal is appear around 1100 per centimeter. That is due to the CO stretching frequency. So in this way we can distinguish acid from ester. So in this way we have discussed these are the compound. Now let's see here one example I am taking over here. Let's see, R is nothing but as a simplest one, then which I am going to write here is a chlorine, acetyl chloride. This is a well known reagent once again. Now here also as a chlorine atom is present, and if you observe the carbonyl frequency, it will appear slightly higher than the ester. It is near about is 1790 per centimeter, or maybe as a near about as I think 1800 per centimeter roughly. So it is higher than this one. So there we can say the factor affecting the carbonyl IR frequency, the factors such as conjugation, then electron donating or electron withdrawing group, hydrogen bonding, these are the some of the factors which can either increase the carbonyl group or decrease the carbonyl group. If you remember here, this chlorine group is a electron withdrawing group. If electron withdrawing groups are present here, the IR frequency of that carbonyl carbon is increased near about 1780 to 1800 per centimeter. And now another strong and the intense peak observed around 500 to 550 per centimeter, which is due to, I think that is not this one, it is near about 800 to 600 per centimeter. This is clearly indicate that the presence of chlorine atom in the organic compound. By observing this type of the signal or the band in IR spectra, the organic chemist can easily identify what type of the functional groups are present in the organic compound. I think with this, let us stop today here. Remaining one we will see in the next lecture. Thank you. Have a nice day.